Good day, sir. I am Aldrian Jheremie Yadao from BSA E1A, and I am here to present my learning video about Introduction to Aviation. The first topic that we are going to tackle is all about history of flight. Leonardo da Vinci. On the 1500s, Da Vinci sketches of flying machines, but his ideas on flying machines was imperfect. Next one is Robert Hooke. Hooke was a mathematician, physicist, and inventor. On the year of 1655, he says that the human have strength to power artificial wings. Next is Joseph and Etienne Montgolfier. They was the pioneer when it comes to flying manned hot air balloon. The balloon flew for more or less 23 minutes in the air. Next is Professor Jacques Charles. After the first flight of manned balloon, Professor Charles flew the first gas balloon in the air. Next is Sir George Cayley. Cayley spent a big part of his life searching to develop a heavier-than-air vehicle that was supported by kite wings object. He also the father of aerial navigation. Next is William Samuel Henson. He was the responsible on designing a huge monoplane powered by steam engine housed inside a fuselage. Next is Otto Lilienthal. He was the man behind and proves that aircraft heavier than air is possible. Next is Wilbur and Orville Wright. These brothers have a 4-year experience when it comes to kite. That is why they are inspired to build the flyer designed and engineered with superior craftsmanship. Next topic that we're going to encounter is all about aircraft structure. Lift opposes the force of weight downward. Next is weight. It pulls the aircraft downward due to the force of the gravity. Drag, retarding the force caused by the disruption of airflow by wing, fuselage, and other producing objects. The last one is thrust, the forward force that comes from the power plant and propeller. Let's proceed to the next slide. The longitudinal. It is also called as roll axis. Through the aircraft nose to tail, it extends with the line passing through the center of the gravity. Next is lateral. It is also called as the pitch. It is the extent across the aircraft on the line through the wings tip. Just like the rolling pitch, it is also passing through the CG, or what we call center of gravity. The last one is vertical, also called as yaw axis, passes through the aircraft vertically. It goes across the center of the gravity. Center of the gravity. It is the point where the whole weight of an aircraft was concentrated. Next topic is all about major components of an aircraft. The first part of an aircraft is the fuselage. It is the main body of an aircraft. It is designed in order to accommodate the crew members, passengers, and also cargoes. Next part is wings. This part is an airfoil that helps lift a heavier than air craft. Wings has different sizes and shapes that fulfill different performances. The number of wings has different classifications such as If it has one set of wing, it is called monoplane, and if it has two set of wings, it is called biplane. Next is empennage. It is an arrangement at the tail of an aircraft to stabilize surfaces. Second to the last part is landing gear. It is used when an aircraft is taking off or landing. It is undercarriage of an aircraft or spacecraft. The last part is power plant. It is the engine of an aircraft. This part function and provide the power to turn on the propeller. And now let us proceed to the fourth topic. It is about types of aircraft construction. The first type of aircraft construction is truss structure. Truss structure is the main drawback of truss structure. It is lack of a streamlined shape. Next is monocoque. Is not highly tolerant for deformation of the surface. For example, an aluminum beverage can support considerable forces at the ends of the can, but if the side of the can is deformed slightly while supporting a load, it collapses easily. The last one is semi-monocoque. Semi-monocoque, partial or one-half, uses a substructure to which that airplane skin is attached. The substructure, which consists of bulkheads and or formers of various sizes and stringers, reinforces the stress skin by taking some of the bending stress from the fuselage. The last topic that we are going to tackle is all about principles of flight. Structure of atmosphere. The atmosphere is an envelope of the air surrounds the earth and rests upon its surface. It is as much a part of the earth as the seas or the land, but air differs from land and water as it is a mixture of gases. It has mass, weight, and indefinite shape. Next is atmospheric pressure. Air is very light, but it has mass and is affected by attraction of gravity. Therefore, like any other substance, it has weight, and because of its weight, it has force. Since it is a fluid substance, this force is exerted equally in all directions, and its effects on bodies within the air is called pressure. The last one is atmospheric density. The density of the air significant effects on the aircraft performance. Because as air becomes less dense, it reduces power because the engine takes in less air. Next is thrust, because a propeller is less efficient in thin air. The last one is lift, because the thin air exerts less force on the airfoils. Structure of atmosphere. The atmosphere is an envelope of the air surrounds the earth and rests upon its surface. It is as much a part of the earth as the seas or the land, but air differs from land and water as it is a mixture of gases. It has mass, weight, and indefinite shape. Next is atmospheric pressure. Air is very light, but it has mass and is affected by attraction of gravity. Therefore, like any other substance, it has weight, and because of its weight, it has force. The first theory of Isaac Newton's is Newton's first law. Every object persists in its state of rest or uniform motion in a straight line unless it compelled to change that state by forces impressed on it. It means that an aircraft at rest on the ramp remains at rest unless a force strong enough to overcome its inertia is applied. Once it is moving, its inertia keeps it moving, subject to various other forces acting on it. These forces may add to its motion, slow it down, or change its direction. Next law is Newton's second law. Force is equal to the change in momentum per change in time. For constant mass, force equals mass times acceleration. This means that takes into account the factors involved in overcoming Newton's first law. It covers both changes in direction and speed, including starting up from rest and coming to a stop. The last law of Newton is Newton's third law. For every action, there is an equal opposite reaction. It is an airplane, the propeller moves and pushes back the air. Consequently, the air pushes the propeller. The opposite direction, forward. In a jet airplane, the engine pushes a blast of hot gases backward. The force of equal and opposite reaction pushes against the engine and forces the airplane forward. Bernoulli's principle of differential pressure. Bernoulli's principle states that as the velocity of a moving fluid increases, the pressure within the fluid decreases. This principle explains what happened to air passing over the curved top of an airplane wing. Airfoil design has the parts chord line, mean chamber line, leading edge, and trailing edge. And that's the end of my video presentation. Thank you for watching and have a nice day.